Use any method to solve the equation 5x squared minus 3x minus 7 is equal to 0. Notice first of all that this is a quadratic equation. We have an x squared term, an x term, and a constant term. So it has the form ax squared plus bx plus c is equal to 0. Now every quadratic equation can be solved using the quadratic formula. The quadratic formula says that the solutions of the quadratic equation have this form. X is equal to minus b plus or minus the square root of b squared minus 4ac all divided by 2a. Now this is a rather complicated looking formula. It always works, but it's not necessarily the most efficient method. So to determine the most efficient method, we can look at the part underneath of the square root symbol, the b squared minus 4ac. The b squared minus 4ac underneath of the radical symbol has a special name. The name that's given to b squared minus 4ac is the discriminant. And we'll use the discriminant test to help decide what the most efficient method is for solving this particular equation. So the discriminant is the part underneath of the square root symbol, the b squared minus 4ac. Well, if b squared minus 4ac ends up being a negative number, then we would have the square root of a negative number, and the square root of a negative number is not a real number, which would indicate that there are no real solutions. So if we use d to represent the discriminant, we can write if the discriminant d is negative, in other words d is less than 0, then there are no real solutions. If the discriminant ends up being 0, we would have the square root of 0, which is 0. And if you add or subtract 0 from a number, it just ends up being that number, and there would just be one solution. That one solution would be minus b over 2a. So if d is equal to 0, then there's just one real solution. If d ends up being a positive number, then we'll be adding and subtracting the square root of that positive number from minus b, and the result will be two different solutions. So if d is greater than 0, then there are two real solutions. Now one other thing to pay attention to is whether or not the discriminant is a perfect square or not. If b squared minus 4ac ends up being a perfect square, then you'll be able to find the square root of that number, and you'll end up with rational solutions. If the solutions are rational, then that means that factoring can be used to solve the equation. So if d is a perfect square, then that means that the equation can be solved by factoring. So I'll just put then factorable. Alright, so let's go ahead and find the discriminant for this particular equation. We identify the A, the B, and the C. Our A is the coefficient of x squared, which is 5. B is the coefficient of x, which is -3. And C is the constant term, which is -7. The discriminant is b squared minus 4ac. So we find the square of -3 and subtract 4 times the a value of 5 times the c value of -7. The square of -3 is 9, and to that we subtract 4 times 5 times -7, and the result is 149. Well, 149 is a positive number, so that indicates that there will be two real solutions. However, 149 is not a perfect square, and that indicates that we won't be able to solve this equation by factoring. We actually do need to use the quadratic formula. So let's write out the solutions. The solutions will be x is equal to the opposite of b, the opposite of -3, plus or minus the square root of b squared minus 4ac. We just found that that number is 149, all divided by 2 times the a value of 5. So x is equal to the opposite of -3, which is 3, plus or minus the square root of 149, all divided by 2 times 5, which is 10. We have one expression. However, this one expression actually represents two different solutions. One solution is 3 minus the square root of 149 over 10. The other one is 3 plus the square root of 149 over 10. So the solution set is the set containing one solution is 3 minus the square root of 149, all divided by 10. And the second solution is 3 plus the square root of 149, all divided by 10.